So you should already know what differential equations are at this point, and a homogeneous one is a differential equation in the form dy over dx equals f of y over x. And the initial equation you're given doesn't have to be exactly in this formula, but you should be able to simplify it to this form. And to solve these, you simply substitute y over x for another variable v. So I have an example right here, dy over dx equals x minus y all over x. And if we simplify this, we get x over x minus y over x, which is just 1 minus y over x. And this is homogeneous because it's a function of y over x. And so we can do, let v equals y over x. So y equals vx. And using this, we're going to be able to replace this dy over dx, because if we replace y over x with v, then we can't set it equal to something that has y. So just take the derivative of both sides here. So dy over dx is equal to dv over dx x plus v, just product rule. And so we get here that dv over dx x plus v equals 1 minus v. And then here we can subtract v from both sides, so it becomes 1 minus 2v. And then this is a separable differential equation. So now we move the 1 minus 2v over to the dv over dx, and then the 1 over x over to the other side. And then now we can solve it. And I'm not going to finish this example, but if you want to, then you can go ahead. Just make sure at the end you replace v with y over x, and then you simplify and isolate y. Now, for an example, let's try to find the solution to this differential equation. X times y times dy over dx equals y squared minus x squared, where y of 1 equals 3. So first, let's isolate our dy over dx by dividing both sides by x times y. So y squared minus x squared all over xy. And then when we separate the fractions, we get y squared over xy minus x squared over xy. And then these cancel out. So we're left with y over x minus x over y. And this is homogeneous because it's a function of y over x. So we can set v equal to y over x, and then y equal to vx, which from that we get dy over dx equals dv over dx x plus v. And then now we substitute everything. So dx turns into this. So dv over dx x plus v is equal to this. We substitute y over x for v, and x over y for 1 over v. Subtract v from both sides. And then now this is a separable differential equation. V dv over dx is equal to negative 1 over x. And then now integrate both sides. Integral v dv is equal to negative integral 1 over x dx. And that turns into v squared over 2 is equal to negative ln absolute value of x plus c. Or v squared is equal to negative 2 ln absolute value of x plus 2c. We can keep the 2c as c because c is a constant. So yeah, once we find it at the end, the 2 doesn't make a difference. So now, okay, I'm going to erase all this so we have more space. But we're left with this first. And now, at this point, we can substitute our y over x back for v. So y over x squared is equal to negative 2 ln absolute value of x plus c. Multiply both sides by x squared equals negative 2 x squared ln absolute value of x plus cx squared. And you don't have to square root both sides. If the question doesn't make you write it in the form y equals f of x, or explicitly tell you need to do that, then you can just leave it as y squared equals this. And so now we can find c. So y of 1 equals 3. which means that 3 squared is equal to 9 is equal to negative 2 times 1 times ln of 1 is 0 plus c times x squared equals 1. So that means c equals 9. And then now, let's plug in c to the equation. So y squared equals negative 2x squared ln absolute value of x plus 9x squared. And that is your final answer for this example. Now, let's do some practice problems. If you think you know how to do this one, pause the video and try it. This one says solve d over dx equals xy plus y squared all over x squared. And first, separate the fraction to 2, so xy over x squared is equal to plus y squared over x squared. These cancel out, and you're left with y over x plus y over x squared. And this is homogeneous because it's a function of y over x. And then you do the same 3 steps you do every single time. V equals y over x, y equals vx, dy over dx is equal to dv over dx, x plus v. Same thing every time. And then now, you replace d over dx with that, dv over dx, x plus v is equal to v squared, so v plus v squared. Subtract v from both sides. And now it's a separable differential equation. So 1 over v squared dv over dx is equal to 1 over x. Take the integral. The integral of v to the negative 2 dv is equal to integral of 1 over x dx. And this is v to the negative 1 over negative 1. So negative 1 over v is equal to ln absolute value of x plus c. And then, to simplify the right side more, we can actually turn this c into ln absolute value of a, where a is a constant. A constant that's not equal to c, obviously, but still a constant, and then we can add that to this natural log. So, the ln absolute value of x plus c turns into ln absolute value of a times x. And then now, we can replace v for y over x. So this turns into negative x over y is equal to ln absolute value of ax. So y is equal to negative x over ln absolute value of ax. And that is your answer for this problem. Now let's do one more practice problem. If you think you can do this one, then pause the video and do it. This one says solve dy over dx equals cosine squared of y over x plus y over x. And this one, it's pretty obvious that it's homogeneous because they just, it's already in homogeneous form when they give you it. And you can just substitute v equals y over x, y equals vx, and dy over dx is equal to dv over dx, x plus v. So dv over dx, x plus v is equal to cosine squared of v plus v. And then subtract v from both sides. And then move the function of v to the other side. And this turns into secant squared over dx is equal to 1 over x. And then now you integrate both sides. So integral of secant squared v dv is equal to integral 1 over x dx. The integral of secant squared v dv is tan v, and that's equal to ln absolute value of x plus c. And we can do the same thing we did earlier. Change this c into ln absolute value of a, and then move it to x. So it turns into this. And then now we have v equals arctan ln ax. And then now we substitute v with y over x, so y equals x arctan ln of a times x. And that's your final answer for this problem. So everything that I explained in this video and all the problems that I went through should give you everything you need to know to start solving homogeneous differential equations. If you learned something from this video, or if you enjoyed it, then please consider liking and subscribing.